Okay, welcome to this video where we're going to be having a look at the chapter that is covering all of trigonometric ratios on the AS Pure curriculum. So you can see on the screen the topics we're going to be having a look at, like the cosine and sine rule, and also looking at solving triangle problems and the graphs of sine, cosine and tangent and their transformations. So before we get started, I just want to show you again how the channel works. Of course, you may already know if you've been following along with the other chapters, but just in case this is the first time you've seen one of these videos, let's just have a quick look. So when you are on one of these videos, if you click into the description, you can see the video there where I cover all of the AS Pure curriculum, and if you scroll down you can also see all of the chapters. Now these will slowly be filling up until it has filled the entire AS Pure curriculum, so hopefully by the time that you are watching this video, all of them will be actually in the description and you can click and watch each chapter. If you click onto the video and click the link in the bottom left there, you can actually see all of the chapters that are within this video as well. So you can skip through and have a look at the pieces of that chapter that you are needing to have a look at for your revision. So that's how this video works. Hopefully that's useful and helpful. If you enjoy this video, please don't forget to like the video, don't forget to share it with some of your friends. But with that being said, let's get started. Something a little bit different here. It says calculate the length of QR. Now QR is this length over here, so let's label that. There we go, that's QR. Now at the moment we don't have the opposite angle. In fact, we don't really have much in this triangle. We have the 14 and that is actually it. But we have got these parallel lines going on, okay? So hopefully we're going to be looking at some parallel line rules here, so something a little bit different. And we have got this right angled triangle, SPR, on the left there. Now on the right angled triangle we've got the length of 8 and an angle. So obviously we can use SOHCAHTOA or potentially the sine rule or something like that to work out one of the missing lengths. Now this one obviously stands out to me because if we can work that one out, that gives us another length in our little triangle on the right there. So let's think how we could do that. So thinking about some trigonometry again, some SOHCAHTOA, we've got this side here which is our opposite. So we've got the opposite and we're looking for the hypotenuse. So we can definitely use SOHCAHTOA to do this. Again, obviously, if you're using formula triangles, let's have a think, SOH. So if we're looking for the hypotenuse, we're going to do the opposite divided by sine 62. So I can work that out, definitely. Let's call that hypotenuse there. Let's just call it the question mark to be fair. So the question mark is going to equal the opposite, which is 8, divided by sine 62. There we go, so sine 62. So let's type that in, 8 divided by sine 62. And that equals 9.06. Let's have a look. So that equals 9.06. And there's a few more decimals. I'm going to leave it like that. This question doesn't actually say. Let's just go for 2 decimal places. Let's go for that. There we go. We're going to do 2 decimal places. So let's label that on the diagram. So we've got 9.06. And obviously if I'm doing it to 2 decimal places, I should probably keep it a little bit more accurate. So it's 0.6056. There we go. But I'm going to keep the answer on my calculator anyway and use that. Now let's look at this right triangle on the right now. Now I have got 2 sides, but yet I'm still missing the angle opposite the one I'm looking for. So there must be something to do with the parallel lines here. And if we have a look, let's just try and highlight this. We actually do have an alternate angle here. So going along our parallel line, it jumps up to here. Moves along, so we've got an alternate angle there. So this particular angle here is alternate with the 62, so that one is also 62 degrees. And now we have all the information that we need in order to use the cosine rule. So opposite that we've got the little a, so this would be our big A, and then these will be our B and C. Let's have a look, and the one that we've just made there will be our C. So we can type that straight into the cosine rule. Obviously not looking at angles here, but we might be looking at angles potentially. But this one's looking for a side length, so a squared equals b squared, so 14 squared, plus c squared, which isn't that 9.06, and again I'm going to leave that in my calculator so I can use that in a sec, and that's squared, minus 2 times 14 times c, which is this 9.06 number, 06, there we go, and that's going to be cos 62. Right, there we go. So let's try typing this in. So obviously I've left that answer in my calculator. So 14 squared plus answer squared minus 2 times 14 times answer, and then cos 62. Again, you can just write it down and not use the answer button if you want. I just quite like just actually using that. So let's have a look. So let's write what we get here. So a squared equals, press equals, we get 158.9908. There we go, 9908. And there are a few more decimals, but again, we'll leave the answer on my screen. So let's square root that. So our value of a, square root answer, and that leaves us with a final value here of 12.609 with a few more decimals. But if we do have that 2 decimal places for this question, that'd be 12.61. And this is all about centimetres. There we go, so 12.61 centimetres, our final answer. So obviously a lot going on in that question. We had some SOHCAHTOA, which, you know, in a different kind of question, could be looking for an angle, it could be looking for a side length. And then we had to apply some cosine rule. And obviously there was a little bit of parallel lines going on in that one as well. So something a little bit different with a blend of different topics, but just something to be thinking about how you could apply this topic, you know, within a different sort of setting or a different sort of diagram that's not just a plain triangle. Okay, so this question says, work out the size of angle x, give your answer correct to 3 significant figures. Now again, just thinking about the question, look, I know we're finding an angle this time, but look, we have got this pair of opposites here, and also we've got a pair of opposites over here. So if I just label this up just like before, we've got A and big A, and B and big B. Okay, but if I was to plug these into my sine rule, formula like we did before, we'd have 6.7 over sine 95. And that would be equal to 5.4 this time over sine x. Now you can actually use the sine rule like this, and obviously we could actually do quite a bit of rearranging here to get that x on its own. But obviously what we want to do is we want to get this part on its own, this sine x part. And if we times that to the other side now, it's going to go onto the top of the fraction here, and it's not really going to be on its own in that first step. So there is a really quick step with the sine rule, obviously just to help you with the rearrangement here, and that's just to flip them over. Now the reason we can just flip them over, if we think about a little bit of logic here, if we have 2 fractions that are equal to each other, let's just pick something easy, like 1/2 is equal to 2/4. Now that is a correct statement there. 1/2 is equal to 2/4, and if we flip them over, we get 2 over 1 is equal to 4 over 2. 2 divided by 1 is 2, 4 divided by 2 is 2, and 2 equals 2 is again a correct statement. So you are able to flip fractions over like this when we're equating them to each other. Obviously they equal different things there, but the statement is still correct. They still have to equal each other. So when we're looking for angles, all we're going to do is we're going to flip the fractions over and use the sine rule upside down, so to speak. So we've got sine A over little a is going to equal sine big B over little b. And you're going to see now when we put the numbers in, we get to rearrange this in one step just like we did before. So if we plug all these values in, I've got sine 95 as my big A, and that's over the opposite there, which is 6.7, and that is equal to sine x. I'll put the x in a bracket just like I do with the normal angles, and that is opposite the 5.4. Okay, so now we are actually able to eliminate or isolate the sine x on its own by getting rid of this 5.4 on the bottom. Let's divide by 5.4. Again, just timesing both sides by 5.4. So when I times this up, and again I'm going to write it in the same way as I did before. So when I times it up to the numerator, look, I'm going to write it just at the start here, and I'll write it down to start with. So that would give me 5.4 sine 95, and that's over 6.7. And that now equals sine x. There we go. So not got the x on its own, but it does equal sine x. Now if I type all of that into the calculator, let's see what we get. So let's type all of that in. So on the top I've got 5.4 sine 95, and on the bottom I've got 6.7. And if I press equals, let's see what we get. So I get quite a long decimal. So we've got 0.802903, and we're not going to write it all down. I'm just going to leave it on my calculator screen for the moment. But that is what all of this little bit on the left here equals when I type it all in. Now obviously that equals sine x. It doesn't equal x, it's not our answer. So that equals sine x, and I'll put the x back in a bracket. Now, this should hopefully link through to normal trigonometry when we were looking at SOHCAHTOA. If you want to separate these two parts out and obviously figure out what x is, we can do the inverse of sine. So I can press that shift sine button and it will do the inverse, and that will help me just to figure out what x actually is and not sine x. So obviously thinking about your normal trigonometry there, press shift and then sine, and you get this sine minus 1, your inverse sine. Okay, and we're going to do the inverse of this value here that's on your calculator. So that'll be the inverse sine. I'm just going to press the answer button. So I'm just going to write ANS here rather than that decimal. But obviously that is just that decimal there that I'm writing in the bracket. You can feel free to write it all in if you want, but it seems like an unnecessary step when we can use our calculator a bit more efficiently here. So shift sine, ANS, which is next to the equals button, close the bracket and press equals, and it gives us the size of the angle, which is 53.408 and a few more decimals, but again it wants me to round it to 3 significant figures, so I can chop it after the 4 and we get 53.5. There we go, and this is about degrees this time, so degrees, and there's our final answer. It's obviously a very similar process in terms of the way we use the formula, but we have that final step there of using the inverse of sine to find out the size of the angle. Okay, just like with normal trigonometry when we're looking at right angled triangles, we still use that inverse of sine when we're looking for an angle. Okay, so this question says the area of the triangle is 105, work out the value of x, and in this case the value of x is the angle there sitting at the top. So if we plug these all into the formula again, we've got area equals, so 105 equals, there you go, half AB sine C, so let's just call that C, and then we've got our A and B here. So it's a half times 15 times the 16 there, times the sine C, and that in this case that is x there, so sine x. Now again, this is quite nice. I'm going to take the quicker approach. I'm going to divide all these pieces straight over. A half times 15 times 16. Again, you could work that out and divide it over. But I'm just going to write all the working out. So I'm going to do 105. I'm going to divide it by a half times 15 times 16, and that's going to equal sine C, or sine x in this case. There we go. So let's type that in. So 105 on the top, and we've got 0.5 times 15 times 16 on the bottom, and it gives us 7/8, or the decimal 0.875. So 0.875 equals sine x. And again, we want to know the value of x here. So just like with all the other trigonometry that we've looked at, when you're trying to find the actual x piece here, or isolate and find the angle, we want to do the inverse of sine. So I'm going to leave that 0.875 on the calculator. Again, it's not too difficult to type that in, but I'm just going to leave it in because it could be a nasty one. I'm going to do shift sine, which brings up my sine minus 1, my inverse of sine. And I'm going to put my answer in, so I'm just going to press the answer button, but I'm just going to put 0.875 in there. There we go, so I want to know what angle gives me that value there for sine. So if I type that in, so shift sine, I'm going to press the answer button and close my bracket, and here we go, I'll get my degrees here, which is 61.0449. There's a few more decimals, but again, we are rounding this now to 3 significant figures as it says up there. So that's the 0, and again, that 4 is not big enough to round it up, so that's going to be 61 point, and I'm going to keep the 0 in there as it wants 3 significant figures. It's just indicating that it wasn't big enough to round it up there. So 61.0 degrees for that question. Very similar process, look, but when you're finding an angle, just like all forms of trigonometry, we have to do that inverse at the end, so the shift sign to get the inverse to get the angle. Okay, so there we go, there's 2 examples, just plugging it into the formula, dividing everything over to the other side step by step, or you can do it all in one jump like I've done on this one. And then obviously just remember when you're looking for an angle, you have to do that shift sign to get the inverse there, to get the angle. Work out the bearing from B to C. So if we have a look at the bearing from B to C, sorry, B from C, then we're going to be having a look at this angle down here, how to get to B from point C. So we're going to try and see if we can work out this angle here. Now we're going to apply a lot of the methods that we did previously in order to get this, because thinking about finding an angle within a non-right angled triangle, we can obviously apply the sine rule or the cosine rule. Now looking at this, if we have a look at this as a triangle, so obviously just highlight some of this, we've obviously got this length here, we know we can work out this angle here, okay, this one here, let me just put, I was going to put a little question mark in there we go, we know we can work this one out, and then thinking about how we might apply some cosine rule or some sine rule to that or something, how could we actually go about that? Now we worked out that angle, we worked out this length, and as long as I have those 2, I can actually do a bit of sine rule. Okay, we can do the opposite pairs here, and we'll have an opposite pair there, or we could actually use the other opposite pair if we were to find the other angle potentially. But the quickest way is going to be for us to just look at a pair that we already have straight away. So actually, if we go about doing some of those steps that we did previously, we should be able to work out any distance or any angle within this triangle. let's have a look at actually going about doing that. And some of the steps we're going to do pretty quick here because we have already looked at this particular question in this particular format, but let's have a look at how we would go about it. So obviously it said it's due east, so we obviously knew this was 90, and we'd already done 210, take away the 90, to get that little angle inside the triangle, which was 120 degrees. And there we are. So we already know that was 120. We then used the cosine rule to get this one here. So we did a squared equals, let's have a look, the other two lengths squared, so we had 6.4 squared plus 3.8 squared minus 2 times 6.4 times 3.8. There we are, cos 120. Right, there we go. Okay, so I'm going to square root that all in one go, just to get the value of a nice and quick. So I'm going to do the square root of 6.4 squared plus 3.8 squared minus 2 times 6.4 times 3.8 cos 120. Pressing equals, there we go, and we get our value here, which was 8.9286. There we go, 9286. There's a few more decimals after that, but I'm just going to leave it as it is. It only wants my answer to the nearest degree here. But if I label that on there then, so let's get rid of the x, and we've got 8.9286, a few more decimals. There we go, as our little value there. So now that we've got that, now we've used the cosine rule, we've got a pair of opposites. Here we are, those two. And we've got another pair of opposites over here, opposite that angle that we're looking for. So we can use the sine rule now to work out one of the angles, and let's just imagine we could also do the same thing if we wanted to work out this angle over here. Obviously once we've got one of the angles, we can work out all of the angles anyway because it's angles in a triangle. But there we go, let's get rid of that. And we'll focus on the actual angle that we're looking for. So when we're looking for an angle, we're going to use the upside down version of the sine rule. So we've got sine A over A equals sine B over B. There we go, sine B over B. So let's just apply all these. So let's say this is A, and this is my little a, and we'll say this is B, and this is my little b. Obviously you can swap and change them if you want. So we've got sine x, our sine A, so sine x over 6.4. What's opposite that? There we go. And that is equal to sine 120. And that is over, what's opposite the 120? The new 8.9286 that we've just worked out. Right, so we can rearrange that. We want to times that 6.4 up to the other side, up to the top there. So we'll have sine x is equal to 6.4 sine 120 all over the 8.9286. There we go. So let's work that out using the fraction button. So 6.4 sine 120, and that's all over 8.9286. I probably could have used the answer button there just to make sure this is super accurate, but as I've left it to 4 decimal places, it's not going to make much of an impact on my answer here. So we get our value of sine x. So we get sine x equals 0.6207, and again a few more decimals, 6207, but we want to find the value of x, so I'm going to do the inverse of sine. So I'm going to get x equals, remember we're doing sine minus 1 here, so shift sine, answer, and we get 38.37 degrees. There we go, 38.37. A few more decimals after that, but it wants it to the nearest degree, so to the nearest degree, x is going to equal 38 degrees. There we go, so 38 degrees. There we are. And it does say work it out as a bearing, so there's one more little step on here. Let's just highlight that down there. There's our last little bit of working out. Right, so now we've got that the angle there is 38 degrees, we need to think about this in terms of a bearing. Now remember the question said the bearing of B from C. Now if we look back at C, there's quite a lot of drawing here, so I might get rid of some of this stuff in a second, and we draw our north line in. This is where this question gets really quite tricky, because obviously we've got the 38 degrees, we kind of feel like that question's finished there. But it wants the bearing of B from C. So really what we have to have a look at is the total angle from north, okay, because it is a bearing, not just that angle. So we need to know not just the value of x there, which is now 38, but the full angle here. So if we get rid of that x, we'll put our 38 in there as we've worked that out. There we go. And we also need to work out what the rest of the missing angle is there. Now there's nothing actually too tricky with working that out, but I'm just going to get rid of some of this working so we can kind of see this a little better. And we'll have a think about how we're going to actually approach this, just this final step here. So if we get rid of that, we've got all of this information now. We know that x is 38, we've worked that out. And let's just get rid of some of this writing here. Get rid of some of that, there we go. Right, so hopefully you can see this a little bit more clearly now. So in order to find that angle, look, if we think about one of the earlier steps we looked at in one of the bearings videos, and that is just thinking about the angles here within these two north lines, within these parallel lines. And obviously those angles there are co-interior, so we can find this angle here if we can find this angle here, because those two add up to 180. Now that angle there on the right is not too difficult to find, because we've got two of the other angles. We've got that this one's 90, and we've got that this one's 120. We're already told that the full angle there was 210, so we can find this one here by taking that away from 360. So 360, take away the 210 that's given to us, and that leaves us with 150 degrees for that angle there. So let's just get rid of some of this working again. So if that angle there is 150, there we are, that's 150 degrees. Given that these two here now add up to 180, that means that this little angle here has to be 30. There we go, 150 plus the 30 makes them add up to 180, as they are co-interior. Right, so now we've got that that is 30, we can now get the total angle of those two. So let's just get rid of some of this again. And let's just think about what we've got there. There we go. So our full bearing then from north going clockwise from to B, bearing of B from C. So from C here down to that line with the B on, that total angle there is going to be 68 degrees. Right, there we go. So the full angle there, the full bearing is 68 degrees. So obviously our answer is going to be 68 degrees, but not forgetting as well, as a final step, it's got to have 3 digits. So that's going to be 0, 68 degrees, and not forgetting that in the final step there. It's always horrible when you finish up a question like this, you've done all this working out, all those steps, and then you just miss out that one last little mark, making sure it's got 3 digits. But that is our final answer, 068. So there's a lot going on in that question. We had a lot of bearings rules, then we had cosine rule, sine rule, and then obviously finding the missing angles using a few more bearings and actually combining that and all, and actually making sure you get the final answer in the end with 3 digits. There's a hell of a lot to think about in that question there, and there's a lot going on and a lot of maths that you've got to be thinking outside the box with as well, because there's obviously you've got to be able to think in the moment, am I actually, what do I need to use here? Do I need to use the cosine rule? Do I need to use the sine rule? So always just try and break it down in steps and have a think about what you're actually trying to find and where you're going with the question. Okay, so when it comes to trigonometric identities and equations, it is essential that you know the trigonometric graphs. So as you can see on the screen, I have 3 of the trigonometric graphs, and it's very important that you are able to do a sketch of these. These are quite accurate, the ones that I've done on the screen, but you need to be able to draw a sketch of them. So you need to know that for y equals sine x, it goes in the origin, and then we have these waves that go up and over every 90, or up and under every 90. So it goes over the 90, down through the 180, under the 270, and then back through the 360. And this graph here goes on infinitely to the left and right of the y-axis, but we need to know how to draw a sketch of that, and you're going to see why in some later questions. For the one below, for the cos graph, this has just been translated, or it's the sine graph which has been translated 90 degrees to the left. So you can see instead it starts at 1 on the y-axis, but then it follows a very similar pattern. It goes down through 90, under 180, up through 270 and up and over 360. And again, this goes on infinitely to the left and right of the y-axis, but it follows this pattern. The tan graph is very different. It does have these waves, and as you can see there are asymptotes at minus 90 and 90, and then each asymptote follows on every 180 degrees, and again that is to the right and to the left of these curves. So you do need to know these graphs, you need to be able to draw basic sketches of them, and this is going to be very helpful when we are solving our trigonometric equations, as I do use a graphical method. Again, there are other ways of solving trigonometric equations, but I do use this graphical method as I do like them, and I do think that it's important that you know these anyway, so it's always good to be able to use them for further elements. So do make sure that you can draw a basic sketch of all of these graphs and you know them very well. So it says here the graph of y equals sine x for x values from minus 270 to plus 270 is shown below. And obviously that is shown on the graph there. We've got minus 270 all the way over to 270 over here. It says on the same axes, draw the graph of, and we've got y equals 1 minus sine x for values from minus 270 to plus 270. So that's the graph we're going to have to draw there, and that doesn't look very nice. Now this is all sort of, this question here is very much linked into graph transformations. We're actually transforming this graph, and we just need to figure out how this graph is transformed, but actually we can actually do this on a calculator. Now this particular graph transformation here has got two different transformations going on, and we could rearrange that. We don't have to write 1 minus sine x, we could write negative sine x plus 1, and just sort of rearrange those if we wanted to. So we could do it like this, we could write minus sine x plus 1. Oh, missed my bracket there, let's put that back in. There we go, plus 1. And think about what these transformations actually represent. So that negative in front of the sine x flips the y coordinates from being positive to being negative. Obviously check out my video, and in fact I'll link that in the description below on graph transformations as well, because it's probably worth checking out because it does link very strongly into these trigonometric graphs. So that negative there relates to a flip or a change of the symbols in front of the y coordinates. We've then got the plus 1 at the end, and again that's outside the bracket. It changes the y coordinate, it changes the y-intercept, it moves the whole graph up by 1. So you could actually take a graph transformation approach to this. You could try flipping it over and then shifting it up 1, and we could probably do that quite nice and quick. I'm going to do it in two different ways though, but just if you are quite keen on your graph transformations, you could first flip it over and just think about that by flip. Oh, that's not my pen, let's just change that. We could take all of these little coordinates here, this one, this one, this one, and this one. I've not bothered with the zeros because they'll stay where they are. And we could just flip them down, change the coordinates there, and that would move the coordinates here. And we actually end up with, and I'll try and draw it. There we go, we end up with that. And then we need to shift it all up by 1. So take all those coordinates, shift them all at 1. That would shift it at 1, that would shift it at 1. Let's have a look. These 0 coordinates need shifting up 1 as well. I'll try and shift them all at 1. It's not the nicest now when you start drawing all over this. There we go. Shift that all at 1. And it makes this sort of curve here. There we go. So drawing it using a graph transformation approach. Let's just get rid of that red one. There we go. That is where our curve ends up following this graph transformation. Okay, not the nicest though, that's quite nasty actually. It's a very sort of horribly difficult graph transformation question, having to sort of flip it over the x-axis there and then actually shift it up 1 as well. But I'm going to take a little bit of a different approach, but just so you know, you could actually take that approach there using graph transformations. So obviously check that video out if you're not sure on that. You can always have a think about what I've actually done there once you've had a look at that. Now instead of doing that, I'm just going to take this nice calculator approach, because this was actually a calculator question as well. So rather than doing that, I'm just going to plug my numbers into this formula here. So I'm going to start with negative 270. So I'm going to do 1 take away, and I'm going to do sine minus 270. There we go. And that's going to give me my first value. So 1 take away sine, and then I'll put minus 270 in the bracket, and I get the value of 0. There we go, so that's my 0. Then I'm just going to change that for the negative 180. So I'm just going to put minus 180. I'm just going back into my calculator and changing that value. That gives me that value there. Back in, negative 90. There we go, and that gives me 2. So negative 90 is up here at 2. I'll put 0 in, and that gives me 1. There we go, we'll put 90 in. And that gives me, sorry, I've put that in, 1 minus 90, yeah, that gives me 0, there we go. Then put 180 in, last one nearly done, and that gives me 1. Where's that gone? 1 is there, and then 270. There we go, and that gives me 2. And that is there. And again, just drawing that up with a nice smooth curve. Best you can. There we go. And there is our transformed graph. But again, two different methods that you could take to approach that. Obviously, if you're really good with your graph transformations, you could have flipped it over first, changed the y coordinates, made them positive, negative, and the negative one's positive, and then obviously shifting it up 1, doing that transformation with the 1 at the end, changing the y-intercept. Or you could just take this approach, just plug in the numbers into the calculator, plot them all nice and neat, and connect them all up together. So it's up to you which one you prefer, but just a couple of different ways that you can actually approach that question. Okay, so this says, here is the graph of y equals cos x between the values minus 180 and 180. And again, we can see that on the graph. It does stretch from minus 180 to 180. It says on the grid, sketch the graph of y equals negative 2 cos x but again between these values. Okay, so taking a little approach to this then. I'm just going to take the calculator approach. Now again, you could take a graph transformation approach to this, but let's have a look at the end and see what that graph transformation is. We'll take that calculator method to start with and just start plugging the values into this formula. So we've got y equals -2 cos x. So on my calculator, I'm just going to type in -2 cos, and I'm going to start with that first value on the x there, which is -180. So -2 cos, and then -180 in the bracket, and it gives me the value of 2. There we go, that equals 2, and I'm just going to do that same approach for all of them. So that 2 goes up to there, and there we go. So back into the calculator. I'm not going to sort of do all the little sub values in between. I'm just going to go straight for -90 and see where that is. So -90 ends up at 0. There we go, so that stays where it is. I'm going to go for 0 now, so back in, -2 cos 0, and that gives me a value of -2. And let's go back for 90, -2 cos 90, gives me a value of 0, and -2 cos 180 gives me a value of 2. There we go, so that value of 2 is there. And again, we just need to join that up with a nice smooth curve. There we go, and that's our point drawn there. So again, that's one method that you could approach. If I swap to a different colour here, we'll have a think about the graph transformation as well. So negative there flips the coordinates over. So I could have actually started by flipping those coordinates over. So let's go about doing that. We've got this one here, which is going to flip to the other side there. 0, that one there stays where it is. This one here on 1 flips down to -1, which I can just about see. It's about there somewhere. We've got the one on the axes then, which stays where it is. And we've got this one down here, which flips up above. So the minus part, okay, just like before, changes the symbols in front of the y coordinates. So we can draw that in. Okay, I'm going to get rid of this in a sec. And just about draw that in, there we go. So that's what the negative part does, and then you've got the 2 there, and again this is all linked to graph transformations, but the 2 is going to double the y coordinates, okay, outside the bracket, not affecting x, it affects the y coordinate, does what we expect, 2 multiplies the y coordinates by 2. So this coordinate here that's currently at 1 goes up to 2, which is there. 0 stays as it is. This one here, which is at -1, goes down to the -2, which we've got here on our actual graph. Again, 0 stays where it is on the next one, and then again finishing it off with this one, that 1 there goes up to the 2. So you could actually take a graph transformation approach again. Again, I think it is actually a bit harder than just type it in on the calculator, but just so you know that there are multiple methods that you could use here. There isn't just one way to solve these sorts of questions. But there we go, that is our final answer there with our nice green line that we've drawn in. Okay, so that is the end of the video looking at trigonometric ratios. The next video we'll be having a look at identities and equations, and again that will be linked to the description. So if you like this video, if it was helpful, please don't forget to like, please don't forget to comment, and don't forget to subscribe to the channel, and I'll see you for the next chapter.